There is a story we have been telling ourselves for decades now, a story so seductive, so deeply woven into our cultural imagination that most people have simply accepted it as an inevitable truth. The story goes something like this. One day, not too far from now, humanity will build its rockets and its ships, will summon its engineering brilliance, and will simply leave. We will spread outward, first to Mars, then to the moons of the outer planets, then to the stars themselves, carrying our biology and our civilization into the vast open arms of the cosmos. It is a beautiful story. It is also, when you sit down with the actual physics, one of the most spectacularly wrong assumptions our species has ever collectively embraced. The problem is not one of engineering ambition. The problem is not that we have not yet built the right rocket, or discovered the right alloy, or written the right software. The problem cuts far deeper than any of those comfortable solvable categories. The problem is that we are sitting at the bottom of a gravitational pit so geometrically severe, so energetically demanding, that the mathematics of escape for massive biological payloads borders on the physically catastrophic. And even if you somehow manage that escape, you would find yourself instantly exposed to a universe that is not neutral, not empty, and not waiting for you. It is actively, relentlessly, and indifferently hostile to the precise molecular architecture that keeps you alive. Let me offer you an analogy that I think captures this reality with the kind of visceral clarity it deserves. Imagine a microscopic organism, not a small creature, a truly microscopic one, the kind that has spent its entire evolutionary history living at the very bottom of the Mariana Trench, roughly 11 kilometers beneath the surface of the Pacific Ocean. Now imagine that this organism decides it wants to launch itself into the stratosphere. It has available to it a single tiny bubble of chemical energy. Perhaps it can release that bubble with some directed force, and as it begins to rise, the crushing weight of 11 kilometers of water presses down on it from every direction. That weight, that immense compressive physical reality, is not just water. It is the fabric of space-time curving inward around the mass of our planet, creating a geometrical depression so deep that everything sitting inside it, including every atom of every human being who has ever lived, is locked in a continuous free fall toward the center. When the organism finally manages to breach the surface, should it survive the depressurization that would instantly rupture every membrane it possesses, it finds itself in an environment of zero pressure, violent ultraviolet radiation, and a complete absence of every chemical compound its biology requires to function. The transition does not liberate it, it destroys it. And this, with the distances scaled outward by many orders of magnitude, is a precise structural description of what awaits biological life attempting to move from the surface of Earth into deep space. Now let us be rigorous about the first layer of this trap, because the mathematics here are not metaphorical. They are devastating, and they are real. Gravity, as we understand it through the framework of general relativity, is not a force in the classical Newtonian sense. It is the curvature of space-time itself, produced by the concentration of mass and energy. The Earth, with its roughly 6 trillion kilograms of mass, creates a pronounced geometrical indentation in the fabric of space-time. We live at the bottom of that indentation. Every object on the surface of this planet is not being pushed downward by some invisible hand. It is following the straightest possible line through curved space-time, and that line curves inward relentlessly toward the center of the Earth. To leave this pit, to achieve what physicists call escape velocity, you need to accelerate a mass to roughly 11.2 kilometers per second. That is approximately 40,000 kilometers per hour. Now, fuel has mass. The rocket carrying the fuel has mass. The biological payload, meaning the human being with all the water and air and food and shielding and machinery required to sustain them, has a very large mass. And here is where the situation becomes what the rocket scientist Konstantin Tsiolkovsky described in his famous equation, an equation so brutally unforgiving that aerospace engineers sometimes refer to its implications as the tyranny of the rocket equation. For every unit of payload mass you want to accelerate, you need a certain mass of propellant. But that propellant itself has to be accelerated too, which means you need more propellant to lift the propellant. And that additional propellant needs propellant to lift it. the relationship is not linear. It is exponential. The ratio of initial mass to final mass grows catastrophically as your target velocity increases. To send a meaningful biological payload with all the life support infrastructure that human biology genuinely requires, on a trajectory to even the nearest star system, would require propellant masses that dwarf the current mass of every manufactured object in human history combined. We are not talking about an engineering problem that better materials will solve. We are talking about a mathematical structure that penalizes biological complexity in a way that becomes asymptotically impossible. And this is only the first layer of the trap. Suppose for a moment we imagine somehow getting past the energetics of the gravity well. We now encounter a second, equally merciless constraint, one that operates not at the level of launch mechanics, but at the level of thermodynamics. The second law of thermodynamics tells us something profound and non-negotiable about the nature of physical systems. Entropy, the measure of disorder within a system, always increases in an isolated system over time. To maintain order, to maintain the biological complexity of a living organism, a cell, a tissue, an organ, a human being, requires a continuous, massive external input of low entropy energy. On Earth, this energy arrives in an almost incomprehensibly generous torrent from the sun. It flows through ecosystems, through food chains, through every metabolic process in every cell of every organism on this planet. Life on Earth is not self-sustaining in isolation. It is perpetually refreshed by an external stellar energy source of extraordinary magnitude. Move that biology away from the sun, and the situation changes with a ferocity that most people have not thought through carefully. At the distance of Mars, solar energy intensity drops to roughly 43% of what it is at Earth. At the distance of Jupiter, it is less than 4%. By the time you reach the outer planets, you are in a regime where solar power becomes essentially negligible as a primary energy source for the kind of rich, redundant, thermodynamically expensive biosphere that human life requires. And in the interstellar void, between our solar system and any other, there is no meaningful energy source whatsoever. The average temperature of interstellar space is approximately 2.7 Kelvin, just barely above absolute zero. It is a thermodynamic desert of a completeness that no engineering intervention currently within the laws of physics can compensate for over the timescales of a human journey. Maintaining a closed biosphere, a self-contained system that recycles air, water, nutrients, and thermal energy while supporting human metabolic processes demands a continuous energy budget of enormous scale. Every inefficiency in recycling, every metabolic byproduct, every gradual increase in system entropy must be actively countered with usable energy input. The further you travel from any stellar energy source, the more impossible this accounting becomes. The second law is not a suggestion. It is a structural feature of physical reality, and it sets a hard thermodynamic boundary on where complex biological life can sustain itself without a local star doing the vast majority of the energetic work. But even these two layers of constraint, as severe as they are, do not fully describe the trap. There is a third dimension to our imprisonment, and it is biological in the most fundamental molecular sense. The universe outside the protective envelope of Earth is not empty in any meaningful physical sense. It is saturated with radiation. Galactic cosmic rays, high-energy protons, and atomic nuclei accelerated to near-light speeds by supernova shockwaves and other violent astrophysical processes stream continuously through interstellar space in every direction. Solar energetic particles, coronal mass ejections from the sun, deliver periodic but intense pulses of charged particle radiation. The ultraviolet and X-ray output of stars fills the electromagnetic spectrum with ionizing radiation capable of stripping electrons from atoms and shattering the covalent bonds that hold complex molecules together. On the surface of Earth, we are shielded from this assault by two overlapping protective systems that are so effective and so ancient that most of us have never needed to think about them for even a moment. The first is Earth's magnetic field, generated by the convective motion of liquid iron in the outer core of our planet, a geodynamo that has been running for billions of years. This magnetic field extends tens of thousands of kilometers into space, deflecting the charged particles of the solar wind and a significant fraction of cosmic ray flux around the planet. Without it, the surface of Earth would receive a radiation dose that would make complex multicellular life essentially impossible to sustain. The second shield is the atmosphere itself, roughly 10 metric tons of air sitting above every square meter of Earth's surface, dense enough to absorb and scatter the gamma rays, X-rays, and ultraviolet radiation that the magnetic field does not stop. Together, these two systems create a radiation environment at Earth's surface so benign that our DNA repair mechanisms, which are themselves metabolically expensive and ultimately imperfect, are sufficient to maintain genomic integrity across a human lifetime. In deep space, both of these shields are absent completely. An unshielded human body in interstellar space would absorb ionizing radiation at a rate that would cause acute radiation sickness within days and would accumulate DNA damage that causes cancer and cellular breakdown over a period of weeks to months. The complex, precisely folded proteins, the lipid bilayer membranes, the double helix of DNA itself, all of these structures are sustained by specific chemical environments and specific radiation conditions that Earth provides, and that space does not. We did not develop resistance to cosmic radiation because our biology evolved within a system that never exposed us to it. We are not adapted to space. We are adapted with extraordinary precision to this specific planet. What this means, when you take all three layers of the trap together, is something that sits at the intersection of humbling and magnificent. Earth is not a cradle that we have been growing in, waiting to leave when we are mature enough. Earth is the precise physical coordinate in the cosmos where the local conditions of gravitational depth, thermodynamic energy flow, magnetic shielding, and atmospheric chemistry happen to align in a way that permits the sustained existence of our particular form of molecular complexity. Remove any one of those conditions, and the molecular architecture of a human being does not struggle. It dissolves. The profound reality is this: we are not trapped by a lack of imagination or a shortage of courage or an absence of technological ambition. We are bound to this planet by the same mathematical structures that govern the behavior of every particle and every field in the universe. The curvature of space-time, the directionality of entropy, the ionizing power of high-energy radiation. These are not obstacles waiting to be overcome by the next generation of engineers. They are the fundamental grammar of physical reality, and they write our location into the cosmos with the precision of a mathematical proof. There is something in this that, if you allow yourself to sit with it fully, transforms from terrifying into something closer to breathtaking. This small, water-covered, magnetically shielded, atmospherically cushioned world is not one of countless options available to our biology. It is, as far as the laws of physics are currently understood to permit, the only address in the observable universe where we can exist at all. Not a convenient address, not a preferred address, the only address. That is not a limitation to be mourned. It is a statement about the extraordinary improbability and the extraordinary preciousness of the conditions that conspired across billions of years of cosmic and geological and biological history to make possible the thing that you are doing right now, which is thinking about it.